Hello everyone, this is Amika Mahajan. Welcome to my channel. In this video, I'm going to discuss case study. This case study is introduced by CBSE in sample paper, second term for class 12. Basically, let's read what is given in this case study. To a distant observer, the light appears to be coming from somewhere below the ground. The observer naturally assumes that light is being reflected from the ground, say by a pool of water near the tall object. Such inverted image of distant tall object causes an optical illusion to the observer. This phenomenon is called mirage. This type of mirage is especially common in hot deserts. Based on above facts, answer the following questions. So this case study is based on total internal reflection. We should keep in mind that total internal reflection takes place only if the ray is traveling from denser to rarer medium and it is falling at interface at an angle greater than critical angle, and this critical angle is given by the relation 1 by sine c equal to refractive index. So let's read the first question. Which of the following phenomena is prominently involved in the formation of mirage in deserts? Obvious, it is refraction and total internal reflection. So from these four options, first option is the correct one. Second question, a diver at a depth of 12 meters inside water with refractive index 4/3 sees the sky in a cone of semi-vertical angle. Four options are there. We have to choose correct one. So this is the situation actually here. Here is the ray, which is along the interface. So naturally this angle in the denser medium will be critical angle. Now if I draw a dotted line here, this will be the semi-vertical angle. And you know, if this is C angle, this angle will also be critical angle. And I know that 1 by sine C equal to mu, which is 4/3. So taking reciprocal, sine C is 3/4. So C will be sine inverse of 3/4. So I was supposed to calculate this semi-vertical angle, which is the critical angle. So from this relation, I have calculated, and correct option is sine inverse 3/4. That is third option. Now, next question, in an optical fiber, if N1 and N2 are refractive indices of the core and cladding, then which among the following would be correct equation? Actually, to find correct relation between refractive index of core and cladding. Here, this is the core inner part having refractive index N2, cladding is outer covering, or you can say outer coating, having refractive index N2. Total internal reflection is taking place. It is possible only if core is having more refractive index. It is denser. So N1 should be greater than N2. So fourth option will be the correct option. Now next question. A diamond is immersed in such a liquid which has its refractive index with respect to air as greater than the refractive index of water with respect to air. Then the critical angle of diamond liquid interface as compared to critical angle of diamond water interface will depend upon nature of liquid only. Decrease, remain the same, or increase. Four options, correct option I have to choose. Now what is given to me? That refractive index of liquid with respect to air is greater than refractive index of water with respect to air. So I am having one liquid and one water. So first, when diamond is in liquid, then if C is the critical angle in diamond and liquid interface, then what happens? What I get 1 by sine C is refractive index of diamond with respect to liquid. So it will be refractive index of diamond divided by refractive index of liquid. These are absolute refractive indices with respect to air. This is first equation. When C dash is the critical angle, when I talk about this interface, which interface? Diamond and water. When water is the medium. So 1 by sine C dash will be this water mu D. So it will be ratio of refractive index of diamond divided by refractive index of water with respect to air. What I find from these two equations, this numerator is same. And we know that denominator, refractive index of liquid with respect to air is greater than refractive index of water with respect to air. It is already given to me. If denominator is more, answer will be less. So 1 by sine C will be lesser than 1 by sine C dash. That means sine C will be greater than sine C dash when I take the reciprocal. So C will be greater than C dash. That means in what this liquid and diamond interface, critical angle is greater. So when I move to liquid and water this diamond interface, then critical angle will increase. So which option will be correct one? Fourth option will be correct one. Now next question, it is again based on optical fiber. The following figure shows a cross section of light pipe made of glass fiber of refractive index 1.68. Outer covering of the pipe is made of material of 1.44. What is the range of the angles of the incident rays with the axis of the pipe for the following phenomena to occur? Now look here. This is acceptance angle. What is acceptance angle? The maximum angle of incidence at which when a ray travels from air to glass fiber. Then when it is incident after refraction on interface of core and cladding from denser to rarer medium, it is incident at angle of incidence I dash greater than critical angle. So it is internally reflected. Same thing happens there. So for total internal reflection to take place, so that light is able to travel from one end to another, this angle should be adjusted. This is angle of incidence I, and acceptance angle is maximum value of that angle of incidence. So this sine of theta A is known as numerical aperture, and this is given by square of refractive index of core minus refractive index of cladding, its square. So when and square root, this is given 1.68, this is 1.44. When I put the value 1.68 square minus 1.44 square and calculate this square root, this comes out to be 0.8653. So this value, if I have to calculate theta A, it will be sine inverse of this value. So I will check the table of sine of angle. So corresponding to this value, what angle I obtain approximates 60 degrees. So this is the maximum angle at which ray should be incident from air to fiber. So this should lie between 0 to 60 degrees. This is the maximum angle. So second option is the correct option. Thanks for watching this video. Like, share and subscribe my channel.